These notes cover arcs and chords. A central angle is an angle whose vertex is at the center of the circle. An arc is an unbroken part of a circle consisting of 2 points on the circle and all the points on the circle between them. Arc ADC is a major arc. That is this guy right here, from A to D to C. The measure of ADC is equal to 360 degrees minus the measure of ABC, and the measure of angle ABC is 93. And so 360 minus 93, you'll get 267. So that's the measure of that major arc. AC is a minor arc. The measure of AC is equal to the measure of the central angle, the measure of angle ABC. So if the measure of angle ABC is 93, then the measure of the arc AC is also 93. If the endpoints of an arc lie on a diameter, the arc is a semicircle. A semicircle measures 180 degrees. Arc-addition postulate. It says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if you're looking for the measure of angle of arc ABC, that would be this guy, you would just add up the two arcs next to each other. AB plus BC. Let's work through some examples. Find each measure. So measure of arc HJ is equal to the central angle, 63. So this is just going to be 63 degrees. If I want to find the measure of arc FGH, let's see, FGH, from F to G to H. All right, let's do some math. First thing that we'll need to do is figure out what the arc GH is. And we can figure out what that angle is because the sum of these three angles is 180. So if I add 65 and 63, that's going to give me 128. And I know it's 180 because this is a diameter. So then 180 minus 128 gives me 52. This guy here is 52. Now if I want to figure out what FGH is, I just need to add these two central angles. So 52 plus 65, and that's going to give me 117. In problem number 3, it says the measure of angle CDE. I'm sorry, arc CDE. So arc C to D to E. Let's see vertical angles, so I know that this is also 40. And then I've got a diameter, and I know a diameter is 180. So if I add up the 40 and the 90, that's going to give me 130. That means that CFB, this angle here, is going to give me a 50-degree angle. All right, so if I want to know what the measure of arc CDE is, I just need to add the 90 plus 40, and that gives me 130. And if I want to find the measure of arc BCD, let's see, from B to C to D, I just need to add the 50 and the 90. And that gives me 140 degrees. In problem number 5, it's asking for the measure of arc LMN. So I'm going to start by highlighting it. From L to M to N. Okay, so let's see what we can do here. Well, we do have a diameter NQ, and so I know that half the circle, the semicircle, is 180. If I add 30 and 105, that's 135. If I subtract that from 180, that's going to give me 45. That means this angle here, MRL, is 45 degrees. Now if I want to find the measure of arc LMN, I just need to add 30 and 45. That's going to give me 75 degrees. Now to find the measure of arc LNP, let's see, L to N to P, that's all of this. Well, let's see. I know that from M to P, this is going to give me 180 if I take this whole, this semicircle here. And so now I can just add, well, 180 plus 45. And that'll give me 225, which is the measure of arc LNP. Congruent arcs are arcs that have the same measure. Congruent central angles have congruent chords. So if the measure of angle BEA, from B to E to A, this central angle here, is equal to the measure of angle C to E to D, then BA is going to be congruent to CD. Congruent chords have congruent arcs. So if BA is congruent to CD, then this arc BA is going to be congruent to CD. Congruent arcs have congruent central angles. So if I know that BA is congruent to CD, then I'm going to also know that BEA, this angle here, is congruent to CED. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. Since AB is perpendicular to CD, and that's given right here with this little box, AB is perpendicular to CD, AB bisects CD and arc CD. So AB is going to bisect this chord and this arc. In problem number 7, it says that QR is congruent to ST. So let's mark that. QR is congruent to ST. Find the measure of arc QR. Well, if these are congruent, we can set them equal and solve for x. If I subtract 3x on both sides, I'm going to find that x is equal to 22. If I want to find the measure of QR, and that's arc QR, I need to substitute that x equals 22 in for the x. So this is going to be 3 times 22 plus 22. So 66 plus 22, and this is going to give me 88. In number 8, we see that the measure of angle HLG is congruent to the measure of KLJ. These are congruent. That means these chords are going to be congruent. So 2y plus 5 is going to equal y plus 13. If I solve for y, subtract y on both sides, and subtract 5 on both sides, I'll find that y is equal to 8. If I want to find what GH is, I need to substitute that in for the y. So 2 times 8 plus 5, 16 plus 5, and I'll find that it's 21. In problem number 9, it says find each length to the nearest tenth. Okay, so we know that LM, let's see, is equal to 10. And so I know, let's see, NP, we're going to draw on a right triangle here. Okay, so let's see. Let's go ahead and let the radius R equal to 6 plus 4. So we know the radius is 10. And I found that by adding these two values here. Well, that means this piece, which is also a radius, is 10 units. Now, by working the Pythagorean theorem, I'll go ahead and just make this a little x right here. X squared plus 6 squared is equal to 10 squared. So x squared plus 36 is equal to 100. And if I subtract 36, that'll give me 64. And if I square root it, that'll give me 8. So I know that this little x that I drew in here is equal to 8. Well, if this is perpendicular, then it's bisecting. So from N to this point here at this intersection is 8. Well, from this intersection to P, this is also 8. So the length of NP is equal to 16. Let's work this one similarly. So we know that this segment here is 17. 8 plus 9 is 17. So, if I were to draw in a radius that connects the center to F, this is also 17. Let's call this little piece x right here. So Pythagorean theorem, 64 plus x squared is equal to 289. Subtract 64, and that's going to give me 225. If I take the square root, this will give me 15. So I know that this little x right here is equal to 15. Since this chord is being bisected, because it's perpendicular, each of these pieces is 15. So the sum from E to F is equal to 30.